Friends, welcome back to a new session. So in this video we are discussing about a given question based on Rolle's theorem, that is x minus a whole raised to m x minus b whole raised to n with the given interval a comma b here. So let's prove the solution for the given question. So let's begin this session. So here the given function is f of x. We can say that f of x which is equal to x minus a with the power m into x minus b with the power n with the given interval is a comma b here. So by the first property of Rolle's theorem, we can say that the given function is in the form of a polynomial. So we can say that a polynomial function is also continuous in the given interval. So it means that the given function f of x which is continuous on the given open interval a comma b here. So it is the first step. In this step 2 we can say that, or we want to find that first f dash of x here. So here two functions are existing. So we can use the product rule to find the derivative of the given function f of x here. So by product rule we can say that x minus a whole raised to m, that is first function into derivative of second plus second function into derivative of first. So the first function is x minus a whole raised to m into the derivative of second, which is equal to n into the derivative of x minus b with the power n, which is equal to n into x minus b whole raised to n minus 1 plus the second function into, that is x minus b whole raised to n into the derivative of the first function. Derivative of first means that m into x minus a with m minus 1th power. So this is the f dash of x. It means that, so note here that there is no need for the further simplification here. So here we can say that the given function f of x which is derivable at the given point open interval a comma b here. So in the third step we want to do that to show that f of a which is equal to f of b here. So the given point is also equal to a and b. The first is a and second is b, that is a comma b here. So the given function is x minus a whole raised to m into x minus b whole raised to n here. So by substituting the value of a and b in the respective function, so we get a solution. That is, when finding f of a first, it means that the given function is x minus a whole raised to m x minus b whole raised to n. So we can replace x as a here, that is a minus a whole raised to m a minus b whole raised to n. Then it conclude that which is equal to, in the case of f of b we can say that, so when finding the value for f of b here, so it means that replace x by b here, that is b minus a whole raised to m into b minus b whole raised to n. So in the next step it become a minus a which is equal to 0 raised to m. It means that the whole term which converted into the value 0 which is equal to the second term is also in the nature of 0, that is b minus b which is equal to 0 in nature also. So we proved the first, second and third step of Rolle's theorem. So finally we can conclude that the f dash of c which is equal to 0, and from this expression of f dash of c is equal to 0 we can find a value of c from the expansion of this term. So in the second step we find that f dash of x which is equal to the given term, then substitute the x by c there, then we get it as c minus a whole raised to m into n into c minus b whole raised to n minus 1 plus c minus b whole raised to n into m into x minus a whole raised to m minus 1, which become c minus a whole raised to m minus 1 there. So here we can say that this whole term which is equal to the value 0. So from this term we want to do further some simplification, that is in the second term we know the value of f dash of x, and where we doesn't do any further simplification, so it is not a problem. So here we want to do some further simplification, so it is must do to find the value of c here. So by further simplification, note here that we want to take some terms as common in both terms here. So it means that we can take c minus b whole raised to n minus 1 into and c minus a whole raised to m minus 1 as a common term. And so in the first term, n into c minus a plus m into c minus b. So this is the form when we taking as c minus b whole raised to n minus 1 into c minus a whole raised to m minus 1 as taken as a common term, and which is equal to 0 also. So when we opening this bracket and do further calculation, so we get a same previous this formula also. So there is no changes as occurring. So here these terms are a constant term, so we can take these terms into the right hand side from the left hand side. So it will become this term which will be vanishes, and we get a solution as n into only this term is existing, n into c minus a plus m into c minus b, which is equal to 0. Then opening this bracket, nc minus na plus mc minus mb, which is equal to 0. And we can write it as nc plus mc, which is equal to na plus mb. That is these minus terms which will be taken into the right hand side from the left hand side. So by taking the here c is common, that is c into n plus m, which is equal to na plus mb here. So the value for c which is equal to na plus mb, which whole divided by n plus m here. So it means that the value c which is belongs to the given point a comma b, hence the Rolle's theorem is proved now. So note here that the given question based on Rolle's theorem, it is also a theorem based or theoretical one. That is the a comma b, which is also a variable, that is it contain many values, that is it contain any numerical values here. So it means that this question is done by a theoretical concept, that is finally we get a constant point c is equal to na plus mb divided by n plus m here. So finally we conclude that this point is belongs to a comma b. So by taking some example for a and b, we can prove this one by the condition under Rolle's theorem. So let's wind up this session, and if you have any doubts about this session and the previous session, so comment your doubts on the comment box. So let's wind up this session and see you soon with a new video. Don't forget to subscribe our channel for more informational videos. Stay tuned with us.